Let's take a look at example 3.19. So it says, win the prize. In a carnival booth, you win a stuffed giraffe if you toss a quarter into a small dish. The dish is on a shelf above a point where the quarter leaves your hand and is a horizontal distance of 2.1 meters from this point. If you toss the coin with a velocity of 6.4 meters per second at an angle of 60 degrees above the horizontal, the coin lands in the dish. You can ignore air resistance. What is the height of the shelf above the point where the quarter leaves your hand? And what is the vertical component of the velocity of the quarter just after it leaves just after it lands in the dish? All right, so we see that you throw it from here and it lands in the dish up here, 2.1 meters away, but we don't know how high it is above that point that you threw it from. Okay, so the questions are asking us to figure out what is this height and what is the final vertical velocity component when it reaches that dish. So I note that the coin is moving in 2 dimensions, so I'm going to list my variables in both the x and y directions. I note that it is a horizontal launch, so because it's a horizontal launch, I'm going to need to go ahead and angled launch. What am I doing? Angled launch. I'm going to have to resolve this into components. So I have 6.4 times the cosine of 60, 6.4 times the sine of 60, and I'll put those in over here. Now, it is also projectile motion. So when I have projectile motion, that means that the acceleration is 0 in the x direction and negative 9.8 meters per second squared in the y direction, because gravity is only acting in our y. Whenever our acceleration is 0, I'm going to say those two values are the same because the velocity is constant, the acceleration is 0, and I'm going to be using equation number 2. Now I can put those angled launch values in here. So I have my 6.4 cosine of 60 and my 6.4 sine of 60. We also have to choose where is x equals 0 and where is y equals 0. So I'm going to choose the lower height as my y equals 0 point and the starting point on the left edge as my x equals 0 point, making this end point 2.1 meters in the x. Now, whenever you have projectile motion, these times are also going to be the same. So typically what you'll have to do is you'll have to solve for time in one of those directions and plug it into the other. So in order to find y and vy, I'm going to need to know the time. So in order to find the time, I'm going to have to solve for it in the x direction. Well, since my acceleration is 0, I'm going to be using equation number 2. So x equals x naught plus v naught xt plus 1/2 at squared, which all goes to 0 because the a is 0. Go ahead, solve for time. So I have 2.1 divided by 6.4 cosine of 60. Make sure your calculator is in degree mode. Also, when you type this in, make sure you put parentheses around that stuff on the bottom. Got to have proper calculator syntax or you'll get some wrong answers. And you should get a time of 1.56 seconds in the air. Now we can use that time over here to solve for the height and solve for that Vy. So I'm going to use equation number 2 to find the height. So y naught plus v naught yt plus 1/2 ayt squared. So it started at a height of 0. So then I have my 6.4 sine of 60 times my 1.56 plus 1/2 times negative 9.8 times 1.56 squared. That gives me a height of 1.53 meters. And you can imagine that the further they put you away from it, the more horizontal velocity you're going to have to give it, meaning it's going to be still moving with that same horizontal velocity for that entire trip. So when it lands on that plate, it's going to want to slide. And so the further they put it away, the harder it is for you to get enough friction when it hits that plate to cause it to stop, thus rigging the game against you. Vy, on the other hand, I'm going to use equation 1. So Vy equals v naught y plus ayt. So Vy is going to be 6.4 sine of 60 plus negative 9.8 times a time of 1.56. And should come out with a number of negative 0.89 meters per second. The good thing about it being negative is it is going down. Yes, you want it to go and land on the plate, not come through the bottom of the plate. So that is good that it is negative. There's that example.